this is Ms. DB. In this video we are going to go over some of the basics about exponential functions. So this is an overview, not everything we need to know about exponential functions, but we'll hit the highlights. So in an exponential function we have a base, that's sometimes called the growth factor, that indicates whether the function will show growth, where it's increasing like this, or decay, where the function is decreasing over time like this. And it will be in the form a times that growth factor, or the base, to the x power. So very important that you see that the exponent is a variable, otherwise it's not exponential. And if the b is between 0 and 1, then it shows decay. If b is greater than 1, then it would show growth. And b has to be greater than 0. It can't be a negative number. We can have negative functions, but then that means that a can be negative, but not b. And here's some more notes about exponential functions. The function always has a variable as an exponent. We talked about that. The domain is usually all real numbers, and the range is usually y is greater than 0. Not always. Sometimes there will be a translation that the range will be different than that. Exponential functions will have one horizontal asymptote. In both of these, that horizontal asymptote is the line y equals 0. You can see that as this x value goes to negative infinity, that it will approach, the function approaches 0. So the end behavior is that it would approach the horizontal asymptote of y equals 0. On the exponential decay function over here, if we look at the function, as x approaches negative infinity, the function will approach positive infinity. It will keep getting higher and higher and higher. But as we go this way, it's going to approach the horizontal asymptote of y equals 0 again. It's getting closer and closer to 0. They will always be either concave up, like both of these are concave up, or occasionally they'll be concave down if a is negative. There won't be any inflection points, because inflection points is when you change from concave up to concave down. They will have a y-intercept, but generally not an x-intercept, because if there's a horizontal asymptote at y equals 0, then they won't ever touch the x-axis. Unless, again, there's been like a translation and the whole thing is shifted down or something like that. There's a note here about graphing these. Because the exponential functions can increase so quickly, you often have to change the scale of the y-axis when graphing. You don't want to just zoom out, because then the x-axis and the y-axis change at the same amount. You actually want to change the scale using the tools in your graphing calculator or Desmos. So what you're going to do for these problems is you're going to look at two graphs and answer the questions. These are both exponential decay. And then on these ones you're going to graph them yourself, and you can make the graphs in technology or you can sketch them here. So you'll probably make them in technology either way, and then if you'd prefer to just sketch it on the paper, you can by looking at your graphing calculator. And then there's some questions about using word problems with exponential growth or decay. So those are the kind of things you're going to have to do. Let's look at like number 10 just to see if we can fill this in. Okay, so this is kind of a standard exponential decay. It's decreasing. The domain would be all real numbers, because there's nothing that x cannot be. But the range, it will never get into the negatives for the y values. It's never below the x-axis. So for the range we would say that y is greater than 0. It's not even equal to 0, because it's never, this is an asymptote here, it'll never actually reach 0. The asymptote of this one is that horizontal asymptote at y equals 0. The y-intercept is at 2. Now let's look at the end behavior. As x goes to negative infinity, that means as x gets smaller and smaller and smaller, what happens to our curve, our graph? It's going to get higher and higher and higher. So it's going to go to infinity. Okay, the other side is as x approaches infinity. So as x gets bigger and bigger and bigger, what will happen to the red line, the curve, the function. And it's not going to go to infinity. It's not going to go up. It's not going to go down to negative infinity. It's going to get closer and closer to the horizontal asymptote of y equals 0. And you can just say it'll get closer and closer to 0 if you want to save yourself some writing there. And then again, these you're going to graph these on your own and either sketch the graph or copy and paste the graph into here and answer those same questions. Alright, let's look at exponential growth, exponential decay. If it's exponential growth, then you will do 1 plus the rate given to you in the problem. Make sure that the rate is changed to a decimal first. If it's decay, if it's decreasing, then you want 1 minus r. So in this example here, it depreciates. That's decay. And this is the rate here, but we want to change our rate to a decimal. So to change percents to decimals, you just move the decimal point over 2 places. So we get 0.15. So when we use this in the formula, we're going to use 1 minus 0.15, which is 0.85. And it was originally purchased for 1,000. That is the A value. And then it's to the t power. However, if we are graphing this in Desmos, they don't have t. We have to use x. So we'll use x for that, and this would be f of x, not f of t. So then you can graph it using technology, and it looks like this. And I changed the scale on the y-axis. I didn't change the x-axis, I changed the y-axis. And I changed it to go from 0 to 1500 so I could get a good view of what's happening. Then often they will ask us to answer a question. So it says use the graph to predict when the value will fall below 100. Well, the cost is along the y-axis, so when it'll fall below 100 is about right here. So you could just estimate that it's going to take like 10, 11, maybe 12 years. But I'm just estimating, looking at the graph. You can find a much closer answer if you actually graph, in this case, that equation, g of x equals 100, and then find the point where they will intercept. And Desmos will let you click there. This is Sketchpad. It let me actually put the point of intersection on the graphs, and then you can find the exact value. So you're going to do that similar. You have 3 problems given to you, and you're going to pick 2 of them to solve. So the first 2 are very much like the example one. Number 15 is a little bit different, and it's based on something that's a little bit more current about a virus that is in Minnesota, and a researcher is tracking it. So there is a exponential model that's fitting the data, and then she revises her data and changes it slightly. So you're going to answer a couple questions about that, and then make sure to attach your graphs if you're you'll be making graphs of this, so do that so that we can check your work there. All right, let me know if you have any questions, and have a great day.